Lesson 510, Rotations and Iterating Angles. The main focus of this lesson is for you to consider the attributes of angle sizes, for you to practice different types of turns and relate them to benchmark angles. But first, let's start with our mental math and fluency. One meter is 100 centimeters. How many centimeters are in 3 meters? Well, in order for 1 meter to equal 100 centimeters, we took 1 times 100. So this time we have 3 meters. So we take 3 times 100, which is 300 centimeters. Again, look at our units. We want to make sure that it's correct for what they are asking. So how many centimeters in 5 meters? Again, 5 times 100 is 500 centimeters. In 15 meters, well, 15 times 100 is 1,500 centimeters. Again, being ready to multiply and know how to multiply is important. For this next part, you're going to need Math Masters page 212. Please pause the recording and go over to the folder and get that so you can do this paper. I want you to trace angle A on a separate sheet of paper and place it on top of angle B. Be careful to align the vertices, which is right here, and rays. So pause the recording now, trace this onto another sheet of paper, and align it over top of this angle, which again is on Math Masters page 212. What do you notice about the two angles? This angle and this angle. I hope you're noticing that the spread of the rays, remember, this is one ray here and one ray here, and this is a ray extending up to the top, and this is a ray extending over to the side, that when you lay them on top of each other, they line up. It's the same in both angles. The size of the angle, this area right here that I'm showing you with my arrow in the inside, the size of the angle within the inside, depends on the spread of the angle's rays and not the length, meaning that even though these rays are shorter, the angle within the two rays is the same as the angle within the two rays that are longer, because look where we're measuring, okay? Therefore, it is incorrect in stating that angle B is larger than angle A. They're exactly the same. So a way to understand the spread of an angle's rays is to think about the way the minute hand on a clock moves away from the hour. These turns are called rotations. They create different size angles. So what direction do a clock's hands move? Look at the two clocks in our room. Which way are they turning? Correct. They turn to the right. So what is another name for this direction? Good. It's called clockwise. It turns clockwise. So what is the opposite direction called? The opposite of clockwise. That would be called counterclockwise. So if it turns to the right, like the normal way it does, it's just called regular old clockwise. If it goes the opposite direction, it's called counterclockwise. So when you look at the clock and you turn completely around and look at the clock again, you made a full turn. If you look at the clock and then turn back towards the classroom, you turn a half a turn. look at the clock and then look towards the front of our room, that is called a quarter turn. So let's take a look at what's displayed on the screen. It asks you to describe the angle by the amount of rotation. So I want you to use the words full turn, 3/4 turn, or half turn. So look at the first angle. Is that a full turn? Well, remember, a full turn would be all the way around. If I was standing facing this way, I would have to turn all the way around and stand facing this way again. That would be a full turn. 3/4 turn? Well, this would be 1/4. This would be 2. This would be 3. So that would be a 3/4 turn. A half a turn would be 1/4 plus 1/4 is 2/4, so I'd be facing the opposite direction. So this is called a quarter turn. On the line, on page 178, you should write quarter turn. And remember, the words are right up here, so you should know how to spell them. So Math Journal, page 178, you should have it open and out. Number 2, what amount of rotation is it if I start at this point and turn all the way around and end looking at that same point? Is that called a full turn, a 3/4 turn, a half turn, or just a simple quarter turn? This is an assessment check, so you're going to need to bring this to me so that I can look at it when you have completed it. If you're still struggling, remember, go to your student reference book, page 207, or rewind this recording, and it should be able to explain it to you again. Number 3 is asking from this point to this point, how much of a rotation it is. From this point to this point, how much of a rotation. This time you're measuring from here all the way around the outside to here. And then I want you to draw your own. Go ahead and pause the recording now. Finish page 178 and turn it on when you've completed it. For this next problem, you're going to need to use a wedge. And a wedge is your purple fraction circle piece. Look at angle CDE on Math Masters page 212. That's what you're seeing on my screen. So if you need to pause the recording, please go get that. What I want you to do is I want you to place the point of the wedge on the angle's vertex. So remember, the vertex is right here where it connects. That kind of makes it look like the letter V. I want you to line up the edge of the wedge with ray DE. So you're going to put that angle's wedge tip point here, and this is ray DE. So you're lining it up with there. I want you to place a second wedge next to the first and make sure its point is also at the angle. And make sure there are no gaps or overlays between the two wedges. So you're laying them in between here just like this arrow is showing you. Repeat doing this until the entire angle is filled. Note that the purple wedge does not fit an even number of times. So you need to estimate how many purple wedges can fit. Remember, you can look at Math Masters page 212 to do this. I want you to explain to me, why weren't all of the measures the same? Well, some of you may have used different side wedges. Do larger wedges create a larger measurement or a smaller one? Good, a smaller one. And why is that? Great, because it takes fewer large wedges to fill up the same amount of space. All right. I want you to turn to Math Journal page 179. It again is asking you to use the different wedges that you have to measure each angle. So it says measurement 1. How many wedges? So first estimate on measurement 2, how many light green wedges will it take to fill in the area for the first angle? Then finish 2, 3, 4, 5, and 6. When you've completed page 179, please do Math Journal page 180. After you've checked page 179 in your Math Journal, I would like you to do Math Journal page 180. This is what the first math box looks like. I want you to figure out 5 times what equals 30, and what times 7 equals 42, and so on. Please complete Math Box 1, and then go ahead and start the recording up again because I'll read every math box to you. Math Box 2 says draw angle JKL. So I want you to draw that hair, and please use a straight edge. What is the vertex? Is it J, is it K, or is it L? Name one ray. And then finally name the other ray. Go back and look at what you just completed if you're struggling with knowing what to do here. Or go to your SRB and look at page 227, 228. So stop the recording now and please do Math Box 2. Math Box 3 says find the area, and it gave you the length and the width. So you should know by now that for area you are multiplying. Please pause the recording now and do Math Box 3. Math Box 4 says Lewis had 55 superhero cards. His brother had 35 cards. They divided them evenly among 9 friends. How many cards did each friend receive? So your number model with the unknown should be if they put them together and divided them between 9 friends, you should have 55 plus 35 first in parentheses, and then divide it by 9, which equals, I would put F as my unknown for friends, and then write your answer here. Please pause the recording and do Math Box 4 now. The next one, number 5, is asking you to divide 42 divided by 6. Notice how at first, because we're just learning a little bit about division now, you always place the larger number first. And then you divide it by the smaller number. If you need to, get out your math fact triangles and use them to find the answers. Finish page 180 of the Math Journal, then go up and check your answers. Anything that you got wrong, please bring back to Mrs. Voorhees or myself, and we will check it and try to help you. Pause the recording now and do Math Journal page 180. The final paper you will need to do for this lesson is Math Masters page 213. It says, make the turns described below. Show which way you face after each turn by drawing a dot on the circle, labeling the dot with a letter. Example, if you face north, do a half turn clockwise on the circle, mark the direction that you are facing with letter A. So as you notice here, if you were facing north, you go a half a turn, you'd be facing south now, and you put the letter A. Please finish Math Journal page 213. Bring it up to me so that I can check it, and you are finished with this lesson. Make sure to do the practice on the bottom, the multiplication problems. Thank you.